Alright, so this is the third edition. This is actually the last thing that we did right before we started this review. This is kind of difficult for the sole fact that honestly, I mean, technically this is area formulas. These are actually easy when you're given all the parts, but when you're not given the parts, it becomes a little bit more difficult. And so I'm going to show you step by step like how this works. First, I'm going to show you the ones that have weird interactions, the area formulas. Otherwise, everything else should be straightforward. Um, Now, when we talk about base, when I talk about the base of something, it's usually the thing that's perpendicular with a little dotted line. So, like the little dot, you'll see a little dotted line, which meaning this is what's always going to be your height. All right. No matter which way I turn this paper, this is still the base, this is still the height. This is still the base, this is still the height, so on and so forth. No matter where I turn this paper, the base stays the same, the height stays the same. I can make a triangle that looks like this. Alright? This is not the base. Even though this is facing the bottom, remember the dotted line determines where your base is. The base and the height are always going to be like kind of essentially perpendicular to each other. Alright? So whenever I say base, that's what I mean. Whenever I say height, that's what I mean. So you have a couple of different formulas that I'm going to go over with. First one is going to be 1/2 height times base 1 plus base 2. This is for a trapezoid. Then I'm going to do 1/2. What is that? 1/2 diagonal 1 times diagonal 2. This is your what is it called? Sorry, forgot what it's called. What is it? Kite and rhombus. And last but not least is a regular polygon, meaning anything that's bigger than four shapes, four sides. We really don't have an area formula for it, unless once again you either dissect it up, or you have all the sides be the same. All the sides be the same, and all these angles are the same. These are called regular polygons, and this is 1/2 base times height. Now, the reason why it's called 1/2 base times height is because you actually make a triangle out of it, and there's always this dotted line that comes out. The base is always going to be the same all the way around here, and so it's 1/2 base times height times the number of sides we have. Now, we have 1, 2, 3, 4, 5 triangles I can create out of this thing if I go from the center here. Which means there's 1, 2, 3, 4, 5 sides. So that's why I say number of sides. So times the number of sides. Okay? That's what this formula means. It means the triangle area formula times the number of triangles we have, or technically just the number of sides of the object. And go one by one through these just to show you how to plug these in so these make more sense. Yeah. So first up is a trapezoid. So trapezoid, pretty distinct shape. You have two bases, all right, with a height connecting them. So let's call this 9. Let's call this 16. Let's call this 24. Okay. The height can either be here, or you're gonna see it like here. But it will never be these diagonal parts here. Alright, these little diagonal sections, if I write them in there, it's just to throw you off. But the area formula for this trapezoid is 1/2 base 1. So these are both bases. No matter how I turn this, once again, the height is connecting them. So these are both bases. So it's going to be 1/2 24 plus 16. I'm sorry, I'm not following the actual formula. It's 1/2 height. So height should be somewhere in there. Times base 1 plus base 2. Okay? Always add this before you put them in the calculator. That way you can just do it pretty simple. You just do 1/2 times 9 times 24 plus 16 is 40. Just straight up put that in your calculator. It'll give you an answer. Um, that's all it means for a trapezoid. For a kite or rhombus, this diagonal thing, it's the dotted lines that are inside of the object themselves. So for example, let me draw a better kite. The one looks like crap. Okay, so let's call this 6, let's call this 9, let's call this 16. Alright, whatever. Alright, so when we're talking about diagonals, I mean this little dotted part and this little dotted part. You might be thinking, oh, those don't look like diagonals. Diagonals are kind of crooked. Trust me, they're diagonals. If I put this to the side, they just become diagonals that way, but this is what it means by diagonals. You're taking one corner to the second corner, two corners to the second corner. That's all it means to be a diagonal, is you take it from one corner that's not adjacent to it, and you just put it right there. That's all that means. So, when I talk about diagonal, I mean the whole length of the diagonal. This little part's 9, this little part's 16. This whole part is 25. Now, with a kite, these two parts right here are the same. But an easy way to remember this is that if you don't have any number in this part, just look to the left or right of it, and it's just the same number. So this is going to be 6, this is going to be 6 too, this whole thing will be 12. So my first diagonal is 25, which was 9 plus 16. My second diagonal was 12, which is 6 and 6. And all I got to do is take the first diagonal times the second diagonal times 1/2. So I just do 1/2, 12 times 25. So that gives me 6 times 25, which is 150. Okay? Now, a rhombus isn't much different. It still has its diagonals as well, but I'm only going to give you half the diagonal. Alright? So if you have 5, you know that this whole diagonal is going to be double that, so that little part's 5, 5, that makes 10. This is 7, 7, that part makes 14. And so once again, this is 1/2 diagonal 1, 10 times 14. Okay? That gives you 70. Alright? That's how that works. Our last little bit is down here, back to the regular polygon. What you'll see is you'll see a little dotted line. You won't have these little lines here, except for the dotted line with a number like, I don't know, 6. And then you'll have 16 here. Okay? So I have 6 and 16. This 16 actually represents all the sides, so this is technically 16 too. But, once again, you're doing 1/2. The base being the sides is 1/2 16 times 6. And then what we also have to do is multiply by the number of sides, which is 5. Okay? So when I do that, so take 0.5 times 16 times 6 times 5, I get 240. So, I mean, that's just an explanation of some of the harder formulas. This is all technically just plug and chug. You just plug the numbers into the formula and you put it in your calculator. Honestly, that's it. The hard part comes when you're left without a letter. Okay, so I'm just going to show a couple examples of X where I give you the area and I give you one part, but I don't give you the whole thing. Let's call that X. Let's say area equals, I don't know, 36 pi. That's for a circle. Let's do a kite. Let's say this entire diagonal right here is x, and then let's call this 6 right here. Okay. And then we're going to do one of these harder ones. Well, this is crappy. Alright, whatever. I don't care. It is. I am not an artist. If I was, I'm going to call this x and then call this 15. Alright, so this area I'm going to say is, I don't know, 240, and this area is, I don't know, 225. Alright, so these are actually a lot easier than you think they are. First, you got to figure out what the formula is. This is a circle, so we know the formula is pi r squared. Okay, that's the formula. Pi. Now the r is our x in this case, so it's going to be pi times x squared. And since this always equals area, we just take whatever this big A is here, we're going to put it right here. That's it. From here, all you're doing is solving for x. So first, I gotta get rid of this pi thing. So I'm gonna first divide by pi. X squared equals 36. And then I'm gonna solve for x. Now remember, this is a square term, so x is gonna give me 6. What that means is that my radius for this thing is 6. Because remember, we're square rooting, which means what number times itself equals the number on the inside. This problem right here. This whole diagonal is x. So since I know this is diagonal 1 times diagonal 2 equals my area. Well, if I take 1/2, let's just call this diagonal 1, so we'll say this is 1/2 times x and diagonal 2. So I gotta figure out the second diagonal going up and down. Well, once again, remember this thing, the 6. If I know this half is 6, I know this half is 6, so I know the whole thing is 12. And I set it equal to what the area is which is 240. All three of these things are multiplying each other, so it should be pretty easy to get x by itself. All you have to do is divide by the stuff that you don't want. So let's divide by 1/2. Now you got to put this in parentheses into a calculator, or you're going to have to use 1/2's equivalent of as a decimal, which is 0.5. So if I take 240 and divide it by 1/2, that gives me 480, yeah. Equals x times 12. Well, x isn't by itself. I'm still multiplying, so now I can just divide by 12. Okay, that gets rid of that. X is by itself now, and now I have 40. X equals 40. So, the last step is this. What we're going to do is we have 15 here, we have x here. Okay? This formula, once again, is 1/2 base times height times the number of sides. That's what I'm going to call n. N is the number of sides. Okay? Let's fill in the information we know. We got 1/2. My base is this thing right here, so that's going to be 15. My height, well, that's the x. And then my n, that's pretty easy to figure out. I got 1, 2, 3, 4, 5, 6 sides. Okay? So, my next step, and we set that equal to 225. Sorry. So my next step is to do this. I'm just going to do exactly the same thing I did right here. I'm going to divide out the stuff I don't need. So let's first divide by 1/2. That crosses out. Divide by 1/2 or 0.5, however you want it. You get 15. X 6 equals 450. Alright, next thing, let's get rid of this 15. That gives me x equals 30. Sorry. X times, here, let me write this again. X times 6 equals 30. Well, I'm still multiplying, so let's divide by 6. Divide by 6. X gives me 5. Okay? So, we have this one. It's just 5. Okay, so all you're doing is you're plugging in everything and just putting the X there. Okay? So, that is how you solve this problem. That's how you solve all these problems. If you have any more questions for me, let me know tomorrow.